Should I do one that is funky and easy? Should I do the last one on your review first? The last one on your review is fun. Are you guys ready? Says find the flux of this in outward direction through the surface of the solid bounded by the paraboloid dot and the z equal to 4. Is this a closed surface? Is it closed? Is surface closed? Yeah, any surface that is contains a volume is a closed surface. Like the simplest thing that you think of, that's a closed surface, yes. Can I use the divergence theorem? Yes. So instead of, see, this was S1, this was S2. If you remember, we made you do the surface integral over S1 of FDS plus surface integral over S2 of FDS. And add them up together, use divergence theorem. That's a pretty part of it. Divergence theorem says this is equal to, see, you're finding things that are getting away from the surface. So you have this volume and things are getting away out of the outer surface of that volume. Divergence theorem says don't compute what is getting away. That would be equal to the entire divergence within. That's what divergence theorem says. It says you do not compute, because the easier way is just to find the divergence of F within as a triple integral. This is a triple integral from section 15.3. That's what divergence theorem says. It says, wait, what are you computing with a flux? With flux, you're computing what is getting away out of the surface. But if the surface is closed, it contains a volume. And that volume, if you compute the divergence over that volume, you're going to get the flux. So don't worry about it. That's the beauty of it. Divergence of this thing is easy. Let's see. Divergence of the F is equal to the first one with respect to X plus the second one with respect to Y plus the third one with respect to Z. All good? Now, all I need to do is to find a triple integral over this volume, dV. Okay, so when you get to the triple integral, what do? Let's remember our triple integrals, right? That's the part that we have to remember. And again, still much easier than finding the surface integrals, basically. So how do I find the triple integral? Here's the story. I'm going to go with the cylindrical coordinates. I know your minds are kind of slipping away, so I'm not even asking you. I'm going to go with cylindrical coordinates. And Z goes from this surface to that surface. So Z goes from x squared plus y squared to 4, right? Convert. That one is r squared, and that one is still 4. Then x and y it's the other bound for x and y is that the biggest circle, basically. So what I need is r. The biggest r I get is right there, which is 4 and 0, and theta is between 0 and 2 pi. What is the Jacobian? Jacobian is equal to r with cylindrical. So now I'm setting it up. Oh, wait a minute. X and Y has to be converted to 6 times R cosine theta, R sine theta. Okay, I converted everything. Let's compute. Triple integral dz runs from r squared to 4. There's an r here. Oops, sorry. Kind of messed up. Let's write it this way. 6r squared sine theta cosine theta dz dr d theta. dr runs from 0 to 4, 0 to 2 pi. And then, so it's integral from 0 to 2 pi, 0 to 4, r squared to 4 of 6r to the third, sine of 2 theta divided by 2. I'm trying to save paper and I mess it up over and over, so it's not saving paper. Integral 0 to 2 pi, 0 to 4, r squared to 4. I'm putting that, simplifying that. dr d theta. And then you compute. And I want the final answer. Good, Angus. Think. Wait, the final answer is going to be 0 because of that thing. So it was beautiful. Turned out to be beautiful, right? Are you guys with me? I could have just skipped this part, and the reason I didn't skip it was because I was tired. Because x, y, z by symmetry, the triple integral of x, y, z by symmetry, we would have gotten it to be 0. Z is always positive, x and y in different octant are opposite of each other, so it would have worked. Just at this point. Okay, guys, I have 20 minutes. Do one more surface integral and then I'll answer a few questions, huh? Quick surface integral, because you guys are getting to that point that you may not even want to do 127 after this. I have to, while ahead, release you from this before you just revolt from 127 and go to the next course, basically.